Download this code from codegive.com, link in the description below. Qualcomm compatibility issues, a deep dive into app and game incompatibility. Qualcomm Snapdragon processors are ubiquitous in Android devices, yet not all apps and games function flawlessly on all Qualcomm-powered devices. Incompatibility stems from several factors, making it impossible to provide a definitive list of incompatible apps and games. Instead, this tutorial focuses on understanding the root causes of incompatibility and how developers, and advanced users, can troubleshoot and mitigate these issues. There's no single code example that universally fixes incompatibility, as the issue is highly context-dependent. Understanding the sources of incompatibility *. 1. Hardware variations *. Qualcomm produces a wide range of processors with differing features, GPU capabilities, adreno, CPU architectures, kryo, and memory configurations. An app optimized for the Snapdragon 8 Gen 2 might perform poorly or crash on a Snapdragon 480. Differences in RAM, storage type, example UFS versus emmc, and display resolutions also play a significant role. 2. Software variations *. Android versions, custom ROMs, and device-specific customizations, vendor implementations, introduce variations in the Android runtime environment, ART. An app compiled for Android 12 might encounter issues on a device running Android 11 or a heavily modified ROM. Driver variations for peripherals, like cameras or sensors, can also be a factor. 3. API level and library conflicts *. Apps rely on specific Android APIs and system libraries. If a device's API level is too low, or if it lacks necessary libraries, the app will fail to function correctly. This is especially true for apps using newer features or technologies. 4. Driver issues *. The graphics drivers, especially those related to the Adreno GPU, can be a major source of incompatibility. Bugs in the drivers or incorrect driver versions can lead to crashes, glitches, or performance issues in games and graphics-intensive apps. 5. Binary compatibility *. The compiled code of an app, usually in APK format, might not be fully compatible with the specific instruction set of a Qualcomm processor's CPU. While the Android runtime handles a lot of this, edge cases and poorly optimized code can still lead to problems. 6. Security measures *. App developers might implement security checks that target specific hardware or software configurations. An app might refuse to run if it detects an unsupported processor or an insecure environment. 2. Diagnosing incompatibility *. Developers should always aim for wide compatibility. The following steps help diagnose problems. 1. Logcat * Android's Logcat provides detailed information about app crashes and errors. Analyze Logcat entries to pinpoint the source of the incompatibility. Requires developer tools like Android Studio. 2. Debugging tools * Utilize Android Studio's debugging features to step through the code and identify lines causing exceptions or unexpected behavior. 3. Device testing * Thoroughly test your app on a range of Qualcomm-powered devices with different Snapdragon processors, Android versions, and configurations. This is crucial to identify and address platform-specific issues. 4. System information * Collect comprehensive system information, device model, Android version, Qualcomm processor model, RAM, storage type, to correlate crashes and errors with specific hardware/software combinations. 3. Mitigation strategies *. 1. Targeted optimization * Developers can optimize their code for specific Qualcomm processor models using conditional compilation or native code, using the NDK. This allows for specialized performance improvements or workarounds for known limitations. 2. API level support *. Ensure that your app uses APIs compatible with the minimum Android version you intend to support. Avoid relying on excessively recent APIs unless absolutely necessary. 3. Dynamic feature modules *. For larger apps, use dynamic feature modules to only download necessary components based on the device's capabilities. This reduces the app's size and makes it easier to handle platform-specific differences. 4. Runtime checks * include runtime checks to detect unsupported hardware or software configurations gracefully. Handle these scenarios with informative error messages or alternative functionalities. 5. Error handling * implement robust error handling mechanisms to catch and gracefully recover from exceptions and unexpected behaviors. 4. Code example, illustrative, not a universal solution. This example demonstrates a simple runtime check for a minimum API level. This is just a very basic check. More sophisticated checks would involve querying hardware capabilities using reflection or accessing system properties. For example, checking for specific GPU features might require using JNI, Java Native Interface, to interact with native code. These more advanced techniques would require significantly more detailed code examples outside the scope of a simple tutorial. Conclusion *. Addressing Qualcomm compatibility issues requires a multifaceted approach. Understanding the root causes, using robust debugging techniques, and employing appropriate mitigation strategies are key to building apps and games that perform reliably across a wide range of Qualcomm-powered Android devices. There is no single solution, and developers must tailor their approach based on the specific incompatibility they encounter. Remember to always test thoroughly on a diverse range of devices to ensure broad compatibility.